Right now, as you're watching this, Earth is exactly what it's supposed to be. Solid ground beneath your feet, blue skies overhead, oceans stretching across 2/3 of the surface. It feels permanent, stable, like it's always been this way. But 4.5 billion years ago, if you could have somehow stood on the surface of our planet, you'd have lasted exactly 0 seconds before being vaporized. Because Earth wasn't Earth yet. It was hell. A molten nightmare of liquid rock and toxic gases. A world being constantly bombarded by meteors the size of mountains. A planet so hot that iron and nickel flowed like water across its surface. There were no oceans, no atmosphere you could breathe, no solid ground to stand on, just endless seething chaos. This is the story of the Hadean Eon, named after Hades, the Greek underworld, the most violent period in Earth's entire history. And here's what makes this period so mysterious. We have almost no direct evidence of what happened. No rock survived. From the early Hadean, everything that existed back then has been melted, recycled, destroyed. We're trying to understand the most important period in Earth's history while missing most of the evidence. But scientists have been piecing together this puzzle using fragments. Tiny zircon crystals that somehow survived, computer simulations of planetary formation, studies of meteorites. And what they've discovered is way more dramatic than anyone imagined. The birth of Earth wasn't gentle, it was catastrophic. A cosmic demolition derby that lasted hundreds of millions of years. Our planet was literally beaten into existence, hammered together from countless collisions. This is the story of how hell became home. Let's go back to the beginning. You're floating in space 4.6 billion years ago. Around a young star, a massive disk of gas and dust is swirling. And within that disk, something is happening. Tiny particles are sticking together. Dust grains no bigger than smoke particles are, colliding, clumping, forming larger aggregates. This process, called accretion, is about to build a planet. At first, it's slow. Dust to pebbles, pebbles to rocks, rocks to boulders. But as these objects grow, their gravity increases. More mass means more gravity means more mass. It's a runaway process. Within just a few million years, these growing bodies become planetesimals, objects hundreds of miles across. Around 4.5 billion years ago, one particular planetesimal had grown large enough to be called a protoplanet. This was Proto-Earth, a ball of rock and metal about the size of Mars still growing. And it was hot, incredibly hot. Gravity compressed its interior. Radioactive elements were decaying, releasing energy. The surface wasn't solid. The temperature was thousands of degrees. What we think of as rock was liquid here, flowing, churning, releasing gases. And the impacts kept coming. Every few years, another massive collision. Planetesimals slamming into proto-Earth at tens of thousands of miles per hour. Each impact released energy equivalent to millions of nuclear bombs. But the worst was yet to come. Around 4.5 billion years ago, another protoplanet, roughly the size of Mars, was on a collision course with proto-Earth. Scientists call this doomed world Theia. And when Theia hit Earth, the energy released was almost incomprehensible. In an instant, both worlds were partially vaporized. A huge chunk of Earth's mantle was ripped away and thrown into orbit. Theia's core merged with Earth's core. And that debris cloud orbiting Earth, it coalesced into a new body, the Moon. Born from catastrophe, the impact reset everything. Earth's surface was now a global ocean of magma, liquid rock extending hundreds of miles deep. The temperature at the surface was over 2,000 degrees Celsius, hot enough to melt iron. The atmosphere was rock vapor, literally vaporized silicates floating above an ocean of lava. This was the Hadean at its worst. This was hell. And it would stay this way for millions of years. Picture Earth 4.4 billion years ago. No continents, no oceans, just a sphere of molten rock, glowing dull red, radiating heat into space. The magma ocean churned with massive convection currents. The surface temperature varied, but nowhere was it remotely cool. The coldest spots might have been 100-200 degrees Celsius. Above this hellscape, the atmosphere was toxic. Carbon dioxide, water vapor, nitrogen, sulfur compounds, all superheated, all under immense pressure. And the sky would have been murky orange-red, thick with particles, occasionally illuminated by meteors streaking overhead. The impacts hadn't stopped. Objects miles across kept crashing into the magma ocean. This is the late heavy bombardment, a steady rain of destruction that wouldn't end for another 600 million years. But slowly, things began to change. The impacts were decreasing, and without constant massive impacts adding heat, Earth finally had a chance to cool. The magma ocean began to crystallize from the top down. The surface radiated heat away, and as it cooled, minerals began forming, the first solid materials in Earth's crust. This fractional crystallization created the first chemical differentiation. Heavy minerals sank, lighter elements rose, the foundation for everything that would come later. And the oldest evidence we have, zircon crystals from 4.4 billion years ago, tells us something shocking. By that time, parts of Earth's surface had cooled enough for liquid water to exist. The magma ocean had solidified, a primitive crust had formed, and water was there. But where did the water come from? This is one of the great mysteries. Earth formed close to the sun, where it was hot. Water should have been scarce. So where did our oceans come from? For decades, scientists thought comets, those icy visitors from the outer solar system. Maybe Earth's water was delivered by comet impacts. But when they analyzed comets, the chemistry didn't match Earth's water. So if not comets, what? Asteroids, specifically carbonaceous chondrites. These primitive asteroids contain water locked in hydrated minerals, and their chemistry matches Earth's water almost perfectly. So most of Earth's water came from asteroid impacts, billions of tons delivered over millions of years. And by 4.4 billion years ago, there might have been liquid water on Earth's surface. Not oceans, not yet, but pools, lakes. The hell was starting to fade. Now let's talk about volcanoes. Hadean volcanoes were nothing like what we see today. They were orders of magnitude more intense. Lava fountains reaching miles into the atmosphere. And they were constant. Multiple eruptions happening simultaneously across the globe at any given time. But these volcanoes weren't just destructive. They were building the first continental crust. As the mantle melted and erupted, it produced magmas enriched in lighter elements, silicon, aluminum, sodium. When these cooled, they formed granite, and this material couldn't sink back into the mantle. It was too light, so it accumulated, forming the seeds of continents. The volcanoes also created the atmosphere. Every eruption released gases: carbon dioxide, water vapor, nitrogen, sulfur dioxide. These accumulated overhead, creating an atmosphere that was dense, hot, and toxic. But it was there, and water vapor would rise, cool, and condense. The first rain in Earth's history fell through that poisonous sky. At first, it sizzled on the hot rocks and flashed back to steam. But gradually, as the surface cooled, some rain stayed liquid. It pooled. It began cutting channels. It began the process of erosion. By 4 billion years ago, Earth had transformed. There was solid crust. There were protocontinents. There was liquid water in genuine bodies. And there was weather. The hell was over. Earth was becoming a world. After 500 million years of extreme violence, we've arrived at the end of the Hadean Eon. Earth went from a global magma ocean to a world with solid crust and liquid water. From chaos to stability, the impacts were tapering off. Volcanic activity was building rather than destroying, and the water was accumulating, because water is where chemistry happens. And by 4 billion years ago, Earth had seas full of it. The conditions were right for complex organic molecules to form. Somewhere near volcanic vents, molecules were forming. Amino acids, nucleotides, lipids, and eventually, something emerged that could replicate. Somewhere between 4 billion and 3.8 billion years ago, chemistry became biology. Life began. The Hadean forged Earth in fire and transformed it into the only world we know that harbors life. Next time, we're diving into the oceans, the first oceans that covered early Earth. We'll explore the mystery of the faint young sun and examine the evidence for the earliest life. Because once life appeared, Earth would never be the same. Thanks for watching. Hit like, subscribe, and let me know what surprised you most about the Hadean. See you next time.